Howdy, folks, and welcome back. So, as you've seen in the last three videos, you've gotten a little bit of a taste of how heat is transferred from one thing to another, the different ways that heat is transferred. Um, and I threatened at the beginning of this module that I would come back and circle back and talk a little bit about the application to climate change. So, one of the things I want to mention really quickly is that we're going to delve deeper into greenhouse gases, the greenhouse effect, and the effect of albedo on Earth's surface energy balance in the next module. Um, and then following from that, we'll then delve into how we've messed up the carbon cycle, and we'll go from there. But what I did want to talk about was mentioning one important thing, which is the impact that clouds themselves have on Earth's climate, and the fact that there's actually a lot of controversy behind this. So before I can do that, I do want to mention that not all clouds are alike. I'm sure that you've experienced this before. If you go outside and you stare up at the sky and you see different types of clouds, some may be puffy, some may be very thin and wispy, others may be dark, others may be very bright, others may be almost transparent, others make the sky look really dark. So not all clouds are alike. And there are many different types of clouds, but I'm just going to split these up into two main categories: high clouds and low clouds. And let's talk about those. So low clouds are clouds that are darker and thicker to our eyes. When we look at them, they just look bigger. They cover most, or they cover more of the sky, and they're not very transparent to sunlight. Hence, they look very dark. These particular clouds are very thick. They're very, very rich in water droplets. And as a result, they're very, very reflective. They're excellent reflectors of solar radiation. And so when sunlight hits one of these clouds, it bounces right off of it. These have a high albedo. Now, on the other hand, they are also a pretty decent absorber of infrared radiation, of that long wave radiation that the Earth is giving off. So their albedo effect is on point, and their greenhouse effect is pretty good as well. That being said, when you add the two effects together, the net effect of low clouds is typically cooling. Everything balanced out, all things being equal, the main effect of low clouds is cooling. However, high clouds have a little bit of a different effect. So if you ever look up and the sky looks kind of milky, you can still see the sun. Maybe it's not as bright, but you can still see it. You can still pick it out. And the sky almost looks clear, but it's kind of milky, or you can tell that there are clouds, but they're very, very thin. Those are high clouds. High clouds don't really reflect a lot of sunlight. Hence, you can still see the sun. Hence, it still feels bright outside. It still may feel like just a normal daytime, maybe just slightly dimmer. Like I said, the sky might look a little milky, but that's about it. But those same clouds, they're primarily made up of ice crystals and water vapor. They're actually excellent absorbers and emitters of infrared radiation. So in these clouds, the greenhouse effect ability that they have is much, much stronger than the albedo effect, the reflectivity of low clouds. So these actually act to warm our climate system up. And so in essence, low clouds reflect a lot of sunlight, cooling us down. High clouds are transparent to a lot of sunlight, and they absorb a lot of the radiation that the Earth is giving off, keeping us nice and warm. So they actually can tend to warm temperatures. All right, so all of that said, as Earth is warming up, how are clouds going to change? Well, a warmer world is going to be a wetter world. Now, that doesn't mean everywhere is going to get wetter. And in fact, many places in the mid-latitudes, such as California, are actually expected to become drier. But there will be more clouds on Earth. Earth will become a cloudier planet. If we see most of that coming in the form of low clouds, that should cool our surface. The cooling effect, that albedo effect, is going to outweigh the blanket effect, the greenhouse effect that clouds cause. On the other hand, if the bulk of clouds that end up developing, the excess clouds that develop as our Earth warms up and more moisture is evaporated and we get more moisture, therefore more clouds, if they end up being high clouds, that will actually warm our surface, because in that case, the warming outweighs the cooling. So with all of that said, high clouds over here do a really good job of letting heat in and not letting it out. Whereas low clouds do a really good job of reflecting heat, preventing it from reaching the surface, while also insulating the surface a little bit, preventing it from getting too cold. But all of that said, as clouds here on Earth change, as the amount of clouds we have, due to changes in moisture and temperature, we're going to see more clouds. Now, there's a big uncertainty on which of these two factors is overall going to actually win over. Scientists in general believe that the net effect on clouds is to cool the Earth. However, as this balance between low clouds and high clouds sort of changes over time, we may actually see a change in the effect that clouds have on Earth. So it's kind of an uncertain factor. It's an uncertain change caused by clouds. Now, in a few weeks, we're going to talk about these things called feedback loops. And in a feedback loop, Mother Nature responds to Earth's warming. And dependent on the different mechanism that's happening, this could actually result in additional warming, or it can actually counteract some of that warming. And so clouds are believed to be something that actually does have an effect on that. If we see more clouds and they're low clouds, that may actually counteract some of the additional warming that we get. On the other hand, if we see more clouds and they're high clouds, that may actually amplify the warming that we're going to get. So the jury is really out on the effects of clouds on climate. But it is important to know that as our world warms up, it's going to become a cloudier world. The type of cloud is going to greatly dictate what these clouds do to Earth's temperature. So that's pretty much it for this module. In the next module, we're going to be talking a lot more about the greenhouse effect. And we're going to be comparing ourselves to our next door neighbor, Venus, and figuring out, why is Venus, even though it's the second closest planet to the sun, why is it so much hotter than the closest planet to the sun? And that'd be Mercury. Why is Venus so much hotter than Mercury? We'll talk about that in the next module.